Welcome to Coach Taylor's class notes, and today, if this little notification is out of the way, we're going to talk about angle relationships. These angle relationships are going to be the key and the basis of everything that we do this year, and we're going to be looking at these relationships in every unit for the rest of the year. So the first one that we're going to look at is complementary angles. And so complementary angles is two angles who have a sum of 90 degrees. So that means that angle 1 plus angle 2 equals 90 degrees. And the other key language I want you to understand is that we call them complements of the other. So if one angle complements another, the two angles equal 90 degrees. So we have a couple of different ways this looks. A lot of the times you're going to see it when we have a 90-degree angle, and we only know it's a 90-degree angle when they write that little perpendicular box right there, or that 90-degree box. And so we'll have 60 degrees and 30 degrees, and we know that those two are complementary angles because they add up to 90. Occasionally, you're going to see two different angles that are separated, that are 60 degrees and 30 degrees, and we know they are complements of one another. So the ones in green are going to be what we call adjacent, A-D-J-E-C-E-N-T, and the other two are going to be non-adjacent. And I'm just going to stop at ADJ. We're going to talk about what adjacent means here in a second. A non-example, or an example of what they would not look like, is if we had a straight angle, because a straight angle is 100 degrees, and these two angles could never be complements because a straight angle, again, is 180 degrees. So next we're going to talk about supplementary angles. So supplementary angles, again, are two angles whose measures have a combined sum of 180 degrees. So angle 1 plus angle 2 equals 180 degrees. Very, very quickly, if you're struggling to remember complementary and supplementary, complementary has a C, and we can very easily turn it into a 9 for 90. Supplementary has an S, which we can very easily turn into an 8 for 180 degrees. And again, we talk about them being a supplement of one another. The most common way you're going to see supplementary angles is when we have a straight angle. And let's say this is 120 degrees and this is 60 degrees. You can occasionally see them when they're non-adjacent, which again, let's say this one's 90 degrees and a right angle, and then this one is also 90 degrees and a right angle. So both sets of these angles add up to 180 degrees. And what I want you to do is I want you to come up with your own non-example or a picture of two angles that are not supplementary. If you need help, go back and look at the class notes and look for the non-examples that I came up with. Our next definition are adjacent angles. So these are two angles that share a common vertex and a side. And so if we were to draw this, we've got just a generic angle, and let's call this A, B, C, and D. So if we've got these two angles here, both angle ABD and DBC have a vertex of letter B. So angle ABD and angle DBC, sorry. DBC. So they both have the same vertex, and if we were to trace these two angles, angle ABD and DBC, you'll notice that we use the same ray twice, and it overlapped. So that's what we mean by share a side, is that if we trace the rays of the angle, they both have the same ray in the middle where they meet. And again, I want you to come up with your own non-example of adjacent sides. If you need help, go look at the class notes, the completed ones. All right, so linear pair. Linear pair is very, very important because linear pair has two requirements. Its two requirements is that the angles are adjacent. We have two adjacent angles, and they are supplementary. So they must be both adjacent and supplementary. So for them to be linear pairs, we have to have a straight angle. Because the only way they can be adjacent is if it is on a straight angle, because we know a straight angle equals 180 degrees. So angle 1 and angle 2 would be a linear pair because they are supplementary and they have this common side and are next to each other. Again, come up with a non-example. Your non-example either has to be not adjacent or not supplementary. All right, our final one is vertical angles. When we talk about vertical angles, the most important thing is that they are congruent. That is the thing we've got to remember, is that vertical angles are congruent. They are going to be the same. So two angles are vertical when their sides form two pairs of opposite rays. So I'm going to kind of show you what we mean by that. So if we've got a point right here, and we've got a ray going this way and a ray going this way. So you might think of this as a line segment. It might be line segment AB with C being in the middle. So when we talk about opposite rays, we're talking about ray CA and ray CB are opposite rays. So that's one pair or one set of opposite rays. And then our other pair or other set of opposite rays would be DE. And so it would be CD and it would be CE. And so what this means is that all of the angles have to share the same vertex and all of the angles have to be on two different lines. So now when we look at this, I'm going to call, no, we don't need numbers. So we know that this angle and its opposite, if they are on two straight lines, are congruent. So angle DCB is congruent to angle AC, not BE. What we also know is that, and I'm going to mark this with two lines to show that these are different measurements but still congruent. We also know that angle DCA is congruent to angle BCE. And so again, all four of these angles have the same vertex because those opposite rays is what gives them the same vertex, but they must be opposite. So again, come up with any non-congruent angles for your example. All right, so now we're going to go through our list of angle relationships. We have complementary, we have supplementary, we have adjacent, we have linear pair, and then we have vertical. So we're going to look at these 6 pictures and determine which of these angle relationships the pictures have. And we're focusing on angle 1 and 2 in each picture. So one real quick note, if a set of angles are adjacent, they cannot be vertical. If a set of angles are vertical, they cannot be adjacent. Those two are opposite definitions and they do not work together. So 1 and 2, they're going to share the same vertex, but they're made up of two pairs of opposite rays. So these are going to be vertical angles. And we know that angle 1 is going to be congruent to angle 2. We do not know if they're complementary or supplementary. We do not have enough information to tell us that. So let's look at angle 1 and angle 2. So we have a straight line right here, which tells us that if we had an angle 3, 1, 2, and 3 would be supplementary, but the picture also gives us this right angle. So if I know that 3 is 90 degrees, I know that 1 and 2 are also going to be 90 degrees. So these are complementary angles, and we know that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. We also know that if we were to trace angle 1, it has the same vertex as angle 2, and if we were to trace angle 2, they both overlap and have the same ray, so they are also adjacent angles. All right, so in this example here, we have a straight line, which means that angle 1 and 2 are going to be supplementary. I'm going to start abbreviating because I'm going to spend too much time writing and make the video too long. So we know the measure of angle 1 plus the measure of angle 2 equals 180 degrees. A quick reminder, if I put this degree symbol, I have to have that M stating that we're talking about the measure of the angle. We also know that angle 1 and angle 2 have the same vertex, and if we draw the angles, they share the same ray, which makes them adjacent. And if they are both supplementary and adjacent, I know they are also a linear pair. And so this one meets 3 different requirements. All right, so this one right here, we have angle 1 and angle 2. We've got a vertex that they have in common. We have a ray that they have in common, so we know they are adjacent. And if they are adjacent, they're not vertical. We don't have a straight angle, so they're not supplementary, and they are not a linear pair. And because we do not have a right angle marker, we cannot say they are complementary. So the only thing that this pair is that we know for sure is adjacent. All right, so let's look at this one here. We've got angles 1 and angles 2. So they share a vertex, and they are on opposite rays. So we know they are going to be vertical. Ooh, can't spell this afternoon. So angle 1 is going to be congruent to angle 2. But we got to look at some more information because this diagram has more information than just vertical angles. So it tells me that this right here is a right angle. And because that right angle is on a straight angle, I know that these 2 angles here also equal 90 degrees. And if we look at these markings here, it tells me that these 2 angles are congruent. So I know that this ray right here is a bisector. So I know I can do 90 divided by 2, which equals 45 degrees. So now I know that angle 1 is 45 degrees, and I know that this is 45 degrees. And because I know that angle 1 is 45 degrees, I also know that angle 2 is 45 degrees. So angle 1 and angle 2 are also complementary, which means the measure of angle 1 plus the measure of angle 2 equals 90 degrees. All right, and our final example. Again, we've got the same vertex, and we've got opposite rays. And since we have 2 pairs of opposite rays, we know they are verticals. We know that angle 1 is congruent to angle 2. Because we have a straight angle here, and this is marked with a 90-degree box, I know that angle 1 is also 90 degrees. And because we've already said that 1 is congruent to 2, we know that 2 is 90 degrees. So these are supplementary angles, and the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And that is an introduction to angle relationships.